Welcome to part 2 of the lecture on classifications of matter. And what we're going to do in this lecture is to classify matter by its properties. Alright, so remember from lecture 1, we classify matter in 3 different ways. We can classify it by its physical state, by its composition, or by its properties. And the physical state and composition is in lecture 1. When we talk about the properties of matter, there are 2 types. There are physical properties and chemical properties. And physical properties are those that can be observed or measured without affecting the identity. So it doesn't change what the substance is. Chemical properties tell us how and when a substance reacts. So examples of physical properties are color, odor, density, what state it is at any temperature. Some examples of chemical properties are flammability. Does it burn? Does it explode? Does it react or does it not react in air or water or acid or base or anything else? The difference between physical and chemical properties are that physical properties tell us what something is, what is its identity, whereas chemical properties tell us what it does, how does it react. There are also physical and chemical changes. During a physical change, a substance changes its physical appearance but not its composition. Whereas during a chemical change, the substance becomes chemically different. Bonds are broken and or formed. There's been a chemical reaction in a chemical change. Some examples of physical changes: you can evaporate water, paint the surface of something, dissolve salt into water. All changes of state are physical changes. So it looks different. For example, when you dissolve salt into water, it looks different, but it's still salt and it's still water. We haven't changed what they are. Examples of chemical changes are, for instance, if you burn hydrogen to make water, when you digest your food, cooking batter to make pancakes. In fact, any kind of cooking is usually causing chemical changes. When metals rust, that's a chemical change. Both compounds and mixtures are composed of 2 or more substances that can normally be separated into their components. At least in theory, they can be separated. And in general, mixtures can be physically separated. 3 examples, which I'm going to go over in a minute, are decanting, filtration, distillation. There are lots of different ways of physically separating things. Any method that takes advantage of physical differences. For example, you might use a sieve to separate particles, for instance rocks, by their size. You can use a magnet to separate magnetic components from non-magnetic. You can evaporate. This would be based on how easy it is to evaporate something. So if you have something that's difficult to evaporate, something that's easy, you can separate them that way. Chromatography is a method based on the polarity of the substances. So any method that takes advantage of physical differences can be used to physically separate a mixture. Now, a compound, we have the components of a compound chemically bonded together, so therefore you have to have a chemical reaction in order to separate them. Let's look at a few examples here. When you decant something, what you're doing is you're pouring the liquid off the top, leaving solids behind. And we're often going to be doing this in lab. It's a fast and easy way of separating as long as the solid stays in the bottom. Filtration is another method of separating mixtures. What we're doing here is we're pouring mixture through filter paper, leaving the solids in the paper. You can see the beaker up there labeled number 1, and you pour the liquid down a stirring rod into the filter paper, and the filter paper holds the solids and the filtrate comes through down into the bottom. Distillation is a common method of separating mixtures of liquids. For example, you can separate alcohol and water using distillation. And this is a picture of distillation setup. What we have on the left is a flask, and let's assume there is alcohol and water in there. You add heat to it, and what we get is vapor. The vapor goes into the condenser. That's the condenser there. The condenser is cold. It has cold water coming into it. There's constantly water circulating around it. That condenses the vapor into liquid, which then runs down into the flask on the right, which contains the distilled liquid. And since alcohol has a lower boiling point than water, you would end up with the alcohol on the right and the water left behind in the flask on the left. If you have a compound, that has to be chemically separated. For example, if you have water, you can do a chemical reaction on it, breaking the bonds between the hydrogens and the oxygens. And in these molecular pictures of the water over there, the oxygen is red, the hydrogen is kind of a bluish color, and bonds are broken, forming hydrogen gas and oxygen gas. Now, this is not evaporation. When you evaporate water, you still have water. It's just in the vapor phase. It's changed its state. That was a physical change. Here you're doing a chemical change. You're changing water into its components, hydrogen and oxygen. And here's a picture of how to do electrolysis of water at home. If you have a battery, for instance a 9-volt battery, take a couple of pencils, use the pencil lids as electrodes, and you put them into the water. Now you have to have something to help carry the charge, so you need to add salt, table salt, or an acid. Perhaps vinegar would be strong enough. And you'll get bubbling at the bottom, and on one side you'll get hydrogen, and on the other you'll get oxygen. So if you want to try that at home, you can do that. One more thing I want to talk about in this lecture is the difference between intensive and extensive properties. Intensive properties don't depend on the amount. Doesn't matter how much you've got. For example, a temperature. Doesn't matter how much you have of a substance, its temperature is what it is. A melting point. MP is melting point. Density, color. All of those are intensive properties. Extensive properties do depend on the amount. So for example, the volume, how much space it takes up, that is something that depends on how much there is. The mass, how much it weighs, that is also an extensive property.